Hello class, today we're going to start chapter 11. We just have two sections we're going to cover in chapter 11. The first one is sequences, the next one is series. So today our learning target is for you to know what a sequence is and how to find the equation for a sequence if it's arithmetic or geometric. So the first thing we need to talk about is what is a sequence. Okay, it's a list of numbers in a particular order. So the terms of a sequence are, they usually say a sub 1. So that 1 means it's the first term. This is the second term, third term. This is just the notation that they see. The Fibonacci is a special type of sequence. It is what we call a recursive sequence. And we're going to look at the Fibonacci a little bit more on the back side of your notes. So it's recursive and it's a famous sequence that we know. So arithmetic. That is a sequence in which each term after the first is found by adding a constant called the common difference. Okay, common difference, and usually we use D to show that, to symbolize the common difference. So if I look to the right, here's an example. I go from -8 to -6, which means I had to have added 2, plus 2. Every time I'm adding 2. So this would make it arithmetic because I'm adding or subtracting the same number. So in this case, my common difference is 2. Now if I go ahead and look at a geometric, what a geometric is a sequence in which each term after the first is found by multiplying the previous term by a non-zero constant called the common ratio. Common ratio, in order to symbolize that, we use the letter R. So let's just look at our geometric sequence we have here. We have 4, then we have 8. If I see that this would be multiplied by 2, every time, I would notice this is geometric, and my common ratio is 2. So we're basically dealing with arithmetic and geometric, and then we're going to take a look at recursive on the back side. So example 1, find the next 4 terms of the arithmetic sequence. So what that tells me is I'm going to be adding or subtracting the same number every time. So I think from 55 to 49, what had to happen? I would subtract 6. From 49 to 43, I would have to once again subtract 6. So 43 minus 6 gives us 37. 37 minus 6 gives me 31. 31 minus 6 gives me 25. And 25 minus 6 gives me 19. So there is my next 4 terms of my arithmetic. Number 2 says find the next 4 terms of the geometric. So geometric tells me that I'm going to be multiplying or dividing by the same number every time. So from 3 to 12, I'd multiply by 4. To get from 12 to 48, I would also have to multiply by 4. So I take 48 times 4, which gives me 192. I take 192 times 4, which gives me 768. I take 768 times 4 gives me 3,072. And one more time, 3,072 times 4 gives me 12,288. Sometimes I'm going to ask you to find the nth term of a sequence. Maybe I'll ask you to find the 150th term. You don't want to have to keep writing it out until you get to 150 terms. So there is nice equations that were, or rules that were written to help us figure that out. So if you're given some arithmetic information about an arithmetic sequence, you can find any term number by using this formula. A sub n, that's the term you want to find. A sub 1, what that shows me, this 1 tells me is it's just the first term. Whatever n is the same as here. And then D, that is your common difference, but you're adding or subtracting every time. Okay. We also have one for geometric, but we're going to go ahead and just look at an example for arithmetic first. The table at right shows typical costs for a construction company to rent a crane for 1, 2, 3, or 4 months. If the sequence continues, how much would it cost to rent the crane for 12 months? Okay, so what we want to know is we want to know the 12th term. Well, that's when n is equal to 12. Okay, so we're trying to find a sub 12 because it's when n is 12 equals my first term. Well, the first term of the sequence, this is a sub 1, so it's $75,000 plus n in this case is 12. 12 minus 1 times the difference. So I need to figure out what the difference is here. Well, to get from 75,000 to 90,000, that's 15,000. To get from 90,000 to 105,000, 15,000 again. So my common difference in this case is 15,000. Now what I do is I look and I see I have all the information. I just need to use my order of operations to solve. So I see what's in parentheses first, and I'm going to solve that. 12 minus 1 is 11. I have to take 11 times 15,000. So 11 times 15, whoops, this is 75,000. Make sure you add that extra 0 on there. 11 times 15,000 is 165,000. And then I would go ahead and add those two, and I would get that my 12th term is 240,000. So what this means is that in the 12th month, okay, for them to rent the crane for 12 months would cost them $240,000. Okay. Example 4. It says write an equation for the nth term of the arithmetic sequence. So we're sticking with our arithmetic sequence. This time it says the nth term, so we don't know what n is. So we solve it without knowing what n is. We need to know what a sub 1 is. So a sub 1 is equal to our first term, which is 8. We don't know what n is, but we could figure out what d is. So d, how do I get from 8 to 17? Well, I would add 9. From 17 to 26, I would add 9. 26 to 35, once again, I would add 9. So my common difference is 9. Now I just fill what I know into my equation. I know a sub n is equal to a sub 1, which is my first term, 8, plus n, I don't know what n is, n minus 1 times d. d is 9. So to go ahead and write the rule, and now I would just simplify. I would notice that this needs to be distributed here. So I would rewrite. I would have 9n minus 9. And then I would go ahead and combine my like terms. 8 minus 9, so a sub n is equal to 9n minus 1. And that is simplified all the way. So now if I wanted to find the 10th term, I would be able to really easily find the 10th term. It's a sub 10 is equal to 9 times 10 minus 1. So this gives me 90 minus 1, which is 89. So my 10th term would be the number 89. Just like there's a formula for arithmetic sequences, there's also one for geometric. So if you are given any number to find the number term, you can go ahead and do so. The formula you would use, and it's written on the front of your sheet of your notes, is a sub n is equal to a sub 1 times r. So remember, r is your common ratio to the n minus 1. And also just remember, a sub 1 is still just your first term of your sequence. So let's look at an example. It says find the 8th term of the geometric sequence for which a sub 1 equals negative 3 and r equals negative 2. If I go ahead, I want to find the 8th term. So that means that n is equal to 8, and it says it's geometric, and I know what a sub 1 is and r is. So I plug everything into this equation. So a sub 8, because I find the 8th term, is equal to my first term, negative 3, and then r is negative 2 to the n minus 1. Well, my n is 8, so 8 minus 1. So I would go ahead, I would have negative 3 to the negative 3 times negative 2 to the 7th. Negative 2 to the 7th is negative 128. Then I would go ahead and take negative 3 times negative 128, which gives me 384. So my 8th term, so a sub 8, that's the notation we use for the 8th term, is 384. Let's go ahead and look at another one, number 6 on your notes. It says write an equation for the nth term of the geometric sequence. 3, 12, 48, 192. So what I need to know is I'm trying to figure out a sub n, okay? But I know what a sub 1 is. A sub 1 is just the first term, so 3. Then I need to know r, my ratio. Well, the ratio is, how do I get from 3 to 12? Multiply by 4. From 12 to 48, multiply by 4. From 48 to 192, multiply by 4. So my common ratio is 4. Then I see that I can go ahead and plug in everything that I know. I do not know a sub n, so a sub n is equal to my first term, 3, times my ratio 4, to the n minus 1. There is no simplifying to be done here, so here is my rule. We are going to go ahead and stop with geometric and arithmetic for today, and we will go ahead and take a look at recursive formulas tomorrow in class. So go ahead and just re-look over those rules. If you have any questions, write them down so you can ask me when you get to class. Have a good day, and I will see you tomorrow.